For section 4.3, we're going to continue by reviewing special right triangles and then doing a little bit of right triangle applications using SOHCAHTOA. Okay, the two special right triangles are the 45, 45, 90 and the 30, 60, 90 triangle. Okay, the 45, 45, 90 is an isosceles triangle. So the two legs are congruent to each other. So let's call this x and x. If I did the Pythagorean theorem, x squared plus x squared equals c squared, x squared equals c squared equals 2x squared, and I square rooted it, I would end up with the hypotenuse being x root 2, where x is the length of the leg. Okay, for the 30, 60, 90 triangle, remember this is an equilateral triangle cut in half. So if the hypotenuse is 2x, this leg is actually x because it's the side of the equilateral triangle cut in half. If I did Pythagorean theorem, I would find that the remaining leg is x root 3. Okay, using these patterns, we could label the missing sides of these triangles without using Pythagorean theorem or trigonometry or anything else. You are welcome to do these in your head. Okay, so let's look at this first one. The first one has a 45 and a 90, so it must be a 45, 45, 90, which means the two legs must be congruent. So since I know that leg is 3, this one must also be 3. And if I follow the pattern, this is x, this is x, this is x root 2, so this is 3, this is 3. The missing side must be 3 root 2. Let's look at the next one. Next one is also a 45 and 90, so it must be 45, 45, 90. The two legs have to be congruent. Since I already know one of the legs is 2 root 5, the other leg must also be 2 root 5. Okay, now let's see. For the hypotenuse, it's going to be x root 2, which I could do in my head. So it would be 2 root 5 root 2. Which simplifies down to 2 root 10. So the hypotenuse is 2 square root 10. Let's go ahead and look at the next one. Still 45, 45, 90. In this case, they've only given me the square root of 10 for the hypotenuse. I need to find both of the legs. Now you could kind of work backwards and say, oh, okay, the hypotenuse is the leg root 2. So the leg must have been root 5, and you could do it in your head that way. If you're a person who likes to have an equation, I could set this equal to x root 2 and then solve for x, or the leg, using that method. If I divide both sides by root 2, then I'll get that x is the square root of 5. So both of the legs must have been square root of 5. And if I double check, if I do square root of 5 times square root of 2, that would match the hypotenuse as square root 10. Okay, for the last 45, 45, 90, again, I'm given the hypotenuse. If in your head you can kind of imagine what you would multiply by square root 2 to get 8, you could jump straight to the leg. If you prefer an algebraic method, I could set the 8 equal to x root 2 and then solve for x to find the missing leg. So what is x? X would be 8 over root 2. I'm going to rationalize that. Okay, so that brings me to a leg of 4 root 2. So both of the legs are congruent, so they both must be 4 root 2. If I want to verify, I'm going to think if I did 4 root 2 times root 2, that would be 4 times 2. That would give me a hypotenuse of 8. So that makes sense with the hypotenuse as well. Okay, the last three are going to be 30, 60, 90 triangles. Okay, and you can do these in your head. I don't mind. Okay, I'm going to look at this. This is the short leg because it's across from the 30-degree angle. So that's the same as this side up here. That is x. The hypotenuse is 2 times x. So if this is 6, 2 times 6 is 12. And the longer leg is x root 3. So since x is 6, this is going to be 6 root 3. Okay, let's go ahead to the next one. It's still 30, 60, 90, just missing the 30 is just not labeled. In this case, they're giving me the hypotenuse. You can do this in your head, I don't mind. The hypotenuse, remember, is 2x. Okay, if you like algebra, because some of you do like equations, I could always do 2x equals 10 and I would get x equals 5. So the short leg must be 5, or x is 5, which means the other leg is going to be 5 square root 3 because it's x square root 3. But you could do that in your head. That's fine. Okay, the last 30, 60, 90 triangle, what are they giving me? They're giving me one of the legs. This is the longer leg because it's opposite the 60-degree angle, which means it's the x root 3 leg. Okay, I could think in my head what x is, or I could do some algebra. If I like to do it algebraically, I could say x root 3 is 12 and solve for x, and then x would give me the short leg. So 12 over root 3, which is 12 root 3 over 3, and that's going to simplify down to 4 root 3. Okay, so this leg must be 4 root 3. Okay, if I did 4 root 3 times root 3, I would go back to 12, so that makes sense. And then for the hypotenuse is twice the small leg, so if the small leg is 4 root 3, the hypotenuse is going to be twice that, so it'll be 8 square root 3. Okay, now we're going to review some right triangle applications that you're going to remember from geometry class. Okay, we are using right triangle trigonometry on this, so we should be using sine, cosine, or tangent. Don't use anything that doesn't apply to right triangles. Okay, so normally when you learn this, I can see that the angle I'm given is 82 degrees. I'm trying to find x. X is the adjacent side. And I'm also given the 35 on the hypotenuse. So I think what trig function involves adjacent and hypotenuse? Oh, that's cosine. Okay, so I'm going to write a cosine equation. The cosine of 82 degrees equals, and cosine is the adjacent over the hypotenuse. Okay, so that's it. This is the trig equation I'm going to start with. I want to see your trig equation. You could probably solve it in your head, but I need to see the trig equation. Okay, now if I'm going to solve this, I'm going to multiply by 35 on both sides. Okay, if I multiply by 35, the 35 cancels, and then I get x equals 35 times the cosine of 82 degrees. Okay, now if I didn't have a calculator and I wanted an exact answer, I would just throw some units on there. Okay, and that would be an exact answer. If you are asked to approximate this, as WebAssign often does, I'm going to say x is approximately, and then I'm going to put this in my calculator. Make sure that your calculator is in degree mode when you enter 35 cosine 82 degrees into your calculator. It should give you about 4.9 feet. Okay, and this is an approximate or a rounded answer, which I don't often ask you for, but WebAssign does often ask you for it, as does your geometry teacher. Okay, example 3 is very similar. Okay, I'm going to look and see the angle I'm given is the 38 degrees. From the 38 degrees, I can see that the 10 is the opposite side, and the x is the adjacent side. So opposite adjacent, I must be using tangent. So the right triangle trigonometry formula is going to be the tangent of 38 degrees equals the opposite over the adjacent side. Okay, this is the equation. I'm going to want to see your equation. How you solve it is kind of up to you. I'm going to multiply by x on both sides. Okay, and then I can divide by the tangent of 38 degrees. Okay, this is a good exact answer. Are there units? There's no units given, so I'm not going to put any units on this. Okay, so that's a good exact answer. Because you don't have a calculator often in this class, that would be a nice answer. If they ask you to put in your calculator, do 10 divided by tangent 38 degrees. Make sure you are in degree mode. You get about 12.8, which seems realistic since it is longer than the leg that is 10. Okay, in this class, you're probably going to get a little bit more interesting of a trigonometry problem than the first two, because those are pretty straightforward. Okay, so if you imagine this is some kind of word problem, it would probably be something like person A and B are standing 250 meters apart and they both spot an airplane in the sky between them. The angle of elevation from person A is 51 degrees. The angle of elevation from person B is 40 degrees. What's the question asking? How high is the plane? Okay, let me think about this. Okay, first I'm going to draw in the height of the plane because that's what I'm trying to find. So let's draw straight down here, H. I'm trying to find H. Okay, I'm looking at this. I see two right triangles right now, so I'm going to see if I can do anything with either of these right triangles. So let's look at this little right triangle here. Okay, this is 90 since the linear pair, it's a linear pair with 90. See, I see that's h, but I don't have the missing side, so I'm going to give the missing side a letter. So if I just look at this little right triangle, I can at least write an equation for the little right triangle. Let's say h and x, that's the opposite and adjacent. So I do know that the tangent of 51 degrees will equal to h over x, because that's the opposite over the adjacent. Okay, now let me look at the other right triangle and see what I can do with that. I still have an angle. I can see the opposite side is h. I'm still missing the adjacent side. I called this part x, and I do know that the entire thing is 250 meters. So if I knew what x was, I could find the red side by doing 250 minus whatever x is. So I'm going to go ahead and call this 250 minus x. And I'm going to write an equation for that, and I'm going to look at it and think about what I could possibly do with this situation. Opposite over adjacent. Okay, now I have two equations. I have two unknowns. This is a system of equations. Now, how you want to solve this is actually up to you, as long as you show your steps. I'm going to use the substitution method. Okay, so I think I'm going to solve for h on both of these equations. So on this first equation right here, I'm going to times x over to the other side. So then I'll have h equals x times the tangent of 51 degrees. Okay, now I could substitute this in now into the other equation, but I think I'm going to make the other equation look a little nicer first. Okay, I'm going to go ahead and multiply this over to here. Okay, and you might want to distribute when you're writing it, because you could. Okay, tangent 40 degrees times 250. I'm going to put the 250 in the front so it doesn't get confused with what I'm doing the tangent to. Minus x times tangent 40 degrees. Okay, even though these don't look great, since they are both equal to h, I can set them equal to each other, which means x times the tangent of 51 degrees, I can set equal to the expression I wrote for h for the other ratio. Okay, now if I had a calculator, I would probably calculator all of this stuff. Okay, but I don't have a calculator a lot of the time, so I'm going to try to solve for x. So to start with, I'm going to get all the x's on the same side. So I already have x tangent 51 degrees here. I'm going to add the x tangent 40 degrees from the other side to this side. And then I still have 250 times the tangent of 40 degrees. Okay, I can factor the x out now so I can isolate it. Okay, and then I'm going to go ahead and divide by the expression in the parentheses. Okay, so I have an expression for x. Okay, now if they want me to find a decimal approximation, I could put this in my calculator. If I put it in my calculator, I think I get about 101.1 meters. Okay, but are they asking me for x? No, they're asking me for h. Okay, so if I want to figure out what h is, I can plug it back into one of these expressions. H equals x times the tangent of 51 degrees. And if I put that in my calculator, I get about 124.8 meters as an approximation, and that seems kind of reasonable in that expression. If you were asked for an exact answer, then I would take this giant expression here, times it by tangent 51 degrees, and then just leave it a big fraction, and that would be a great exact answer.